Batteries. A good supply of electric power is necessary for modern vehicles. The engines require a large current to operate the starter motor, and many other systems are electrically powered. All modern cars use a 12-volt system. The majority of vehicle batteries are of conventional design, using lead plates in a dilute sulfuric acid electrolyte. This features leads to the common description of lead-acid batteries. The output from a lead-acid battery is a direct current, DC. A rechargeable battery is an electrochemical unit that converts an electric current into a modified chemical compound. This chemical reaction can be reversed to release an electrical current. The modified chemical compound in the batteries, which is available as electricity when connected to the circuit. A few batteries have open cells that require routine maintenance to the electrolyte level. This usually consists of adding distilled water at regular intervals. Most modern lead-acid battery designs have improved plate constructions and the case design, which with precise alternator charge control allows maintenance-free types to be used. A vehicle 12-volt battery is made up from 6 cells. Each lead-acid cell has a nominal voltage of 2.1 volt, which gives a value of 12.6 volt. 12.6 volt, not 20, I'm sorry, for a fully charged battery under no-load condition. The 6 cells are connected in series internally in the battery with lead bars. The cells are formed in the battery case and are completely separate from each other. Each cell has a set of interleaved positive and negative plates kept apart by porous separators. The separators prevent contact of the plates, which will give an internal short circuit and affect the chemical reaction in the battery cell. The cell plates are supported above the bottom of the case. This leaves a sediment trap below the plates so that any loose material that falls to the bottom does not cause a short circuit between the plates. The cell plates are formed in a lattice grid of lead antimony or lead calcium alloy. The grid carries the active material and acts as the electrical conductor. The active materials are lead peroxide for the positive plate and the spongy lead for the negative plate. When a battery is in charged state, the positive of plates of lead peroxide are reddish brown in color, and the negative plates of spongy lead are gray in color. When the battery is discharging, a chemical reaction with the electrolyte changes both plates to lead sulfate. Applying an electric current to the battery reverses the process. The charged battery stores chemical energy. This can be released as electrical energy when the battery is connected into a circuit. The electrolyte is dilute sulfuric acid, which reacts with the cell's plate material during charging and discharging of the battery. Sulfuric acid consists of hydrogen, sulfur, and oxygen. These chemicals separate during the charge and discharge process and attach to the cell plate active material or return to the electrolyte. During discharge, the sulfate combines with the lead to form lead sulfate. The oxygen into the positive plate is released to the electrolyte and combines with the hydrogen that is left to form water. During charging, the reverse process occurs with the sulfate, leaving the cell plates to reform with the hydrogen in the electrolyte to produce sulfuric acid. Oxygen in the electrolyte is released to reform with the positive cell plate material as lead peroxide. Near the fully charged state, some hydrogen and oxygen may be lost as gas from the battery vent. Some water can also be lost by vaporization in hot weather. With older batteries, this meant that battery electrolyte needed a regular inspection and topping up. Only water is lost from the battery, and therefore only water should be used for topping up. Any contaminants will affect the chemical reaction in the battery and therefore the performance. Only distilled or specially produced topping up water should be used. Tap water is not suitable for topping up a battery. Acid should never be used, as this will strengthen the acid solution and alter the chemical reactions. Most modern batteries, however, include vapor traps and other features to minimize water loss and therefore need little or no attention. The electrolyte chemical composition changes with the state of charge. It is possible to measure this change using a hydrometer. Sulfuric acid is denser and provides greater buoyancy than water. This property is called specific gravity or relative density. Water, which is used as the basis for measurement of all liquids, is given a value of 1 for readings at 50 centigrade. The dilute sulfuric acid of the electrolyte of a fully charged battery cell has a reading of 1.280. The reading for a half-charged battery cell is 1.2, and for a fully discharged battery is 1.150. As most batteries are sealed to the voltage of the battery can be used to indicate battery condition. A fully charged battery will give a reading of 20.6 volts and the discharged battery 20.0 volts. Measurement of battery condition by heavy-duty discharge should only be carried out on a fully charged battery. Heavy-duty discharge is carried out with a specialist item of equipment. This consists of connecting low-value resistor in circuit with the battery for a few seconds and measuring the value drop. This test applies a load similar to that of the starter circuit. In general, the voltage should not fall below 10 volt. Battery performance can be determined by its ampere-hour rating, but this is also affected by the ambient temperature. A cold battery will have a poor performance in a comparison to a warm battery. A more useful measure of battery performance is its reserve capacity rating. This refers to the time taken in minutes for a battery to discharge to a cell voltage of 1.75 volt when supplying a constant current of 25 ampere. This test reflects a typical current drop for a vehicle that will be needed if the charging system failed during night driving. The reserve capacity of 40 ampere-hour battery will be approximately 60 minutes. Another measure is the cold cranking amps rating, which is a measure of the maximum current that can be supplied for a period of 30 seconds before the battery voltage falls below 7.2 volt. This is carried out of minus 80 centigrade, so that is represent the most severe condition of cold engine starting. The cold cranking maps CCA rating of a battery is an important measure in regions that suffer very cold winter temperatures. Some maintenance-free batteries incorporate a built-in hydrometer to indicate the state of charge and the condition of the battery. The hydrometer is color-coded, which is a green color indicates that the battery is charged and serviceable. A green-black or black color indicates the battery requires recharging. A yellow color indicates that battery is faulty. Where a yellow hydrometer is showing the battery should not be recharged or tested, and the use of jump leads for starting should not be carried out. A new battery should be fitted and the alternator checked for a correct operation. Battery charging can be described as slow or fast. Slow charging is best, but in an emergency a fast charge is acceptable. When recharging, a battery should ideally disconnected from the vehicle electrical systems. There are two types of battery charger: a bench charger, which has a current output of up to 10 ampere hours, and the fast charger, which can recharge battery in 30 minutes with a current of up to 50 amps.